Welcome to this explainer, where we're going to absolutely demystify Headroom's reversible compression architecture. Look, if you're an AI developer, you already know the absolute headache of managing context limits, right? It's literally the modern developer's equivalent of running out of RAM in the 90s. We're constantly battling between giving the AI enough information to actually be smart and managing those skyrocketing token costs. But what if that battle was just over? Today, we're looking at a true paradigm shift for developers dealing with AI context limits. Okay, let's dive right into a staggering number, 70 to 90%. I really want you to just imagine for a second cutting your LLM token usage by 70 to 90% on your very next bill. Normally, to get numbers like that, you'd have to completely butcher your prompts or just throw away huge chunks of relevant data. But the innovation we're looking at today achieves these massive token savings with absolutely zero risk of data loss. None. Zilch. It honestly sounds like magic, but as you'll see, it's just incredibly clever engineering. Here's our roadmap for today. 1. The AI compression dilemma. 2. Introducing reversible compression. 3. The four-phase architecture. 4. Smart search and context. And 5. Maximum savings, zero risk. Let's get to it. All right. Section 1. The AI compression dilemma. So, every single day, you face this brutal trade-off. On one hand, you've got aggressive compression. You chop down your data to save a few bucks, but in doing so, you risk losing the exact critical data the LLM needs to actually give you a good answer. It just leads to hallucinations and failed logic. Then, on the other hand, you have conservative compression. You play it safe, you pass absolutely everything the model might possibly need, and, well, you completely miss out on valuable token savings, burning through your budget incredibly fast. It's this frustrating lose-lose situation that's pretty much plagued AI development from the start. Moving right along to Section 2, Introducing Reversible Compression. This is where we change the game. Enter CCR, which stands for Compress, Cache, Retrieve. This is an architecture that finally makes compression reversible. So when your content is compressed, that original data isn't just tossed into the void. Instead, it's cached locally. And this guarantees that if the LLM suddenly realizes, hey, I need the full uncompressed data to answer this, it can instantly get it back. With Compress, Cache, Retrieve, nothing is ever permanently thrown away. You get all the savings of aggressive compression, but it is entirely lossless. A real game changer. Okay, Section 3, the four-phase architecture. Let's take a look under the hood. So you might be wondering, how does the model actually get that data back? Well, Headroom executes this flow in exactly 4 seamless phases: compression store, tool injection, response handler, and context tracker. And honestly, the best part? These phases happen completely transparently during your API calls. Your end-user client never even knows this complex dance is going on in the background. Let's break those down a bit. In Phase 1, we have the compression store. When Headroom Smart Crusher compresses the tool output, it securely tucks the original full-size data into an LRU cache. That's a least recently used cache, so it stays highly accessible locally. It then generates a unique hash key for that specific piece of data. Finally, a tiny marker containing that hash key is seamlessly added to the compressed output that actually gets sent over to the LLM. Now, this is where it gets incredibly smart. Think of Phase 2 and 3 kind of like giving the LLM a library card instead of making it carry around a heavy backpack full of books. In Phase 2, Headroom automatically injects a special tool called Headroom_Retrieve into the LLM's available tools. Then, in Phase 3, if the LLM looks at the compressed data and says, wait a minute, I need more detail here, it simply calls that retrieve tool using our hash marker. Headroom's response handler intercepts this call, grabs the data from the local cache in a blazing fast 1 millisecond, adds it right back into the conversation, and the API call just continues automatically. It resolves instantly, fetching exactly what it needs. And again, the client application is completely oblivious to the magic happening behind the scenes. Finally, we have Phase 4, the context tracker. Now, this isn't just a simple one-and-done operation. Across multiple turns in a conversation, the context tracker maintains this deep, multi-turn awareness. It actually remembers exactly what was compressed in earlier turns. So when a new query comes in, it analyzes it for relevance against the cached content. If it spots a connection, boom, it proactively expands that relevant data back into the context window before the LLM even has to ask for it. It literally anticipates the model's needs. Moving to Section 4, Smart Search and Context. Let's look at some advanced capabilities. CCR isn't just about basic one-to-one retrieval, it gets significantly smarter when handling vast amounts of context.
First up, the LLM doesn't have to retrieve an entire massive payload if it only needs a tiny piece of it. It can actually use an optional query parameter to run a BM25 keyword-based search directly over the compressed data, pulling back only the specific relevant subset of cached items. Furthermore, CCR works at the message level. If Headroom's intelligent context drops whole, low-importance messages just to fit within your context budget, the LLM can still use those markers to recover specific messages later on. And here is the absolutely brilliant part: TOIN learning. It's a feedback loop system. When users retrieve messages that were previously dropped, the system actively learns from this. It essentially realizes, oh, okay, that message pattern was actually important. It then scores similar messages higher in future sessions, which continuously improves drop decisions across all users. The system literally gets smarter every single time it makes a mistake. Looking at the full technical stack here, you can see how different components leverage this architecture in their own unique ways. Smart Crusher handles JSON arrays from tool outputs, storing the original array and injecting a hash marker. Content Router handles the heavy text stuff like code, logs, and search results, storing the original content based on specific routing strategies. An Intelligent Context, which we literally just talked about, handles conversation messages, storing any dropped turns and passing along that all-important hash marker. Basically, every part of the context is covered. And that brings us to Section 5, Maximum Savings, Zero Risk. Let's look at the bottom line. It all really comes down to this bottom line right here. Look, if you use no compression, sure, you have no risk, but you get absolutely zero savings. If you use traditional compression, you might get 70 to 90% savings, but you are completely burdened with the heavy risk of permanent data loss and those dreaded model hallucinations. But with Headroom's CCR compression, you get the absolute maximum 70 to 90% token savings of aggressive compression, but with none of the risk. Because it's completely reversible, your risk of data loss drops to exactly zero. You truly get the best of both worlds, and you don't have to compromise your application's intelligence. I want to leave you with this provocative thought as we wrap up today. We've spent so long as developers defensively coding around token limits and memory constraints, aggressively pruning our context just to keep things running. But when token costs and context limits are completely out of the way, when you can compress aggressively and retrieve instantly, what will your LLM build when it never has to forget? Thanks so much for joining me for this explainer, and I really hope you leave with a clear understanding of the incredible power of reversible compression. See you next time.